Hello folks, Mr. Ray here with our next grade 10 academic lesson in quadratics. Today we're going to be looking at how to create a fairly easy graph of a quadratic that's given to you in Vertex form. I want to emphasize the difference between sketching a graph and sketching a quadratic and graphing a quadratic. Sketching a quadratic, it's fairly rough. It just gives you a pretty good idea of where that quadratic is, the general shape, and definitely has the vertex. It has the exact coordinates of the vertex. It knows whether it's opening up or down, and basically whether it's stretched or compressed or neither. So it's fairly just a quick sketch based on A, H, and K. This process we're learning today is a more detailed. Every point we put on the curve is exact, but it's a much quicker way of getting the points that you need in order to provide a good graph. It's not. Sometimes it's good enough just to do like a random table of values, but the key to drawing, graphing a quadratic is knowing where the vertex is. And if you're just randomly plugging in x values, you may not even get close to where the vertex is. So this process ensures that you'll get the vertex, you'll get 2 points to the left of the vertex, 2 points to the right, and you'll get a really good shape of what that quadratic looks like. So without further ado, let's look at the process. So the first part that I want to talk about is what's a base point. Okay, we kind of know what transformations are from earlier lessons in this unit, but a base point. So you're going to see this more in grade 11 as well. We're just looking at quadratics this year, but every type of function has a set of base points, and those base points basically give you the key points in order to provide a good graph. So we're just looking at the graph of y equals x squared, and we call this the base function or the base equation. Okay, so every time we do a graph of any quadratic, we're going to start with the 5 points that define what this graph looks like. And those 5 points always have the same x values, x equals -2 through to +2. And if I go down here, you can see the table of values for the base points. So you got 5 base points. So there's your x values I just talked about, -2 through 2. The y value is basically you're squaring the x value. So I want you to notice the symmetry of these points. So you've got 2 points that have a y value of 4. You've got 2 points that have a y value of 1. And then you've got 1 point in the middle. Now that point in the middle happens to be the vertex. So, and it was no accident that we picked these 5 points. We wanted the vertex to be right in the middle, and then we've got 2 points to the left, 2 points to the right. And then the whole process of this will be to transform each of these 5 points with the transformations required to graph our full quadratic equation in this form here with the a, h, and k values. Okay, so every time we do this process, this is the first thing you do. You just repeat these base points. It's always going to be the same. Very repetitive, I know, but we need to work from these to come up with our new table of values for the new equation. So this is what the graph looks like. You definitely don't have to draw this. I'm going to break this out into steps. So it'll seem pretty long, but at the end we'll just put all the steps together and then just do one transformation. So so the first step is to get the base graph, and using those same points every time, this is the graph of y equals x squared. Okay. Now remember to talk about this, we're going to do the example where this is our this is our graph, okay? This is our equation, y equals 2 bracket x minus 3 squared plus 2. And what I always want you to do is strip out the values of a. So a is 2, h is 3, positive 3, and k is positive 2. We're going to be using those to come up with our new points. Okay, so on the next step, we're going to handle the a value. So in this case, our a value was 2 from before. So the way the a value affects the points, the base points, is it multiplies whatever the y coordinate is by that a value. So basically the x values stay the same, and the y values get multiplied by a times y, which in this case is 2 times y. So basically that means from the previous table of values, when they were 4, 1, 0, 1, 4, we just multiply every single one of these by 2, and we get 8, 2, 0, 2, 8. Okay? So that new graph would look like this. And it looks pretty similar to the one we just looked at. The difference being that the parabola is now stretched by a factor of 2. Okay, you can see it's a little bit narrower than the original graph. Notice also that the vertex has not changed. It's 0, 0 in the original graph. It's still 0, 0. So remember, the a value does not affect where the vertex is. So we've applied the a value. What we're going to do now is apply the translations, the h value and the k value. Okay, so h is responsible for the horizontal, moving left and right, and that affects your x coordinate. So what we're going to do is we're going to actually add the value of h to x. So in our case, h was 3, so we're just going to say x is now equal to x plus 3, and you can see down here, these are the original x values from the previous step, and we're going to add 3, and the new x coordinates are 1, 2, 3, 4, 5. Okay, they're always going to be a nice pattern going up by 1, no matter what value of h you add. Okay. Now, if I was to apply the k value, remember the k value moves the parabola up and down, so that's affecting your y coordinate. So in this case, we would just add the value of k to the y coordinate. So in our case, k was 2, so y is equal to y plus 2. And so in this case, we took our previous y coordinates from up here, 8, 2, 0, 2, 8, and we just added 2 to them. So now we get 10, 4, 2, 4, 2. Okay, and so now we've applied the value of a up here in this step. We've now applied h and k also, and now this is our final graph. So this is the graph of y equals 2 times x minus 3 squared plus 2. You notice that the vertex is at 3, 3, 2, the point 3, 2. If we looked at our table of values here, remember the vertex all along at the beginning and at this point as well, the vertex is always going to be your middle point. So 3, 2 is right there, and then I got 2 points that I plotted on the left side and the right side. So that's our final graph. Now, we didn't really have to do this in 2 steps. Okay, we could have just done it in one big step where we're applying the a value and the h and k values at the same time. So that's what we're going to do here. Combine those steps 2 and 3 into one bigger step. So you notice, and now we're starting back with the original x coordinates, -2 through +2. We're starting also with our original y values of 4, 1, 0, 1, 4. So what we're doing with h is just what we did in the last step. We just add the value of h, which in this case is 3, to the previous value of x. So again, they're just like they were before, 1, 2, 3, 4, 5. And the difference here is we're first multiplying the y value by a, because a is a multiplier. It changes by a factor of, which means it's multiplying. So we multiply the previous y coordinate by a, which in this case was 2. So it's 2 times each of the previous y coordinates, 4, 1, 0, 1, 4, and then we add the value of k. So we basically got this little mini formula that the new y coordinate is equal to 2y plus 2. We can do that in basically one step now, and we get the same y coordinates as we did before, and you'll notice the graph is exactly the same as the last page. But this time we just did it in one step. So that's going to be the process. Okay. One thing that's important to notice is when you apply when you're looking at the y coordinate that you're changing, you have to multiply by a first before you add k. Okay, and that's just BEDMAS. BEDMAS says multiplying always happens first, so we do not add k first and then multiply that result by a. That would be wrong. So it's always ay plus k. You calculate ay first and then add k. Okay, so here's the kind of the key concepts here. So in order to graph any quadratic relation in vertex form, we create a table of values with these base points where x is -2 through +2, and then for the x values we're going to apply the transformation. The only transformation that affects the x coordinate is the h parameter, so we add h to the x column of values. Then we apply the y transformations. This one is a little more complicated because there's 2 transformations. So we multiply the previous value of y by a, and then we add k. And then this table that we just created, table of values, we got 5 points. The middle point is always the vertex, and then we just plot those 5 points on a graph. Draw a nice smooth parabola, and we're done. Okay, so I've got 2 examples here that we're going to go through. First one, y equals 4 times x plus 1 squared minus 5. So the first thing I'm going to do is write out the values of a, which is 4, h is -1, and k is -5. Okay, and I don't have a whole lot of room here to work with. It'd be better if you used a bit more space than I'm going to here, so avoid silly mistakes. But I'm just going to fit it in here to show you that you can do all this work in a confined space. So this is my base points. And remember, this is the same. I always start from this for any equation. So this is x and y equals x squared. So this is the basic parabola with no transformations. So -2, -1, 0, 1, 2, always the same. And then y would be the value squared. So remember, negative times negative, +4, 1, 0, 1, 4. So these are our base points. You don't have to write this every time, but I am just so you know where they're coming from. Then I'm going to put my little arrow here. It's going to kind of show you the transformation, the process that happens. And I guess I'm just going to repeat my a equals 4. I'm going to put the k value here because a and k kind of work together. And that's -5, and the h value is -1. Okay, so now I'm going to create another table. I'm going to make this one a little bit wider, just because there's more going on here. Again, I've got my x column and my y column. So remember that this column here is going to be x plus h all the time. So I go and fetch my h value, -1. So x plus -1 is the same as x minus 1. And then this column here, the y, that's going to be the generic formula is ay plus k. So that's going to be a is 4, so 4y, and then plus k, which is -5, 4y minus 5. Okay, now, so when you're doing these transformations, very highly recommended let's just do all the x's first and then do all the y's. Don't be going back and forth because it gets confusing as to what you're working with. So I'm going to start with this value -2 and I'm going to subtract 1. So that's -3. Then I'm going to take -1, subtract -1, -2, 0 minus 1, 1 minus 1, and 2 minus 1. You notice the pattern here we talked about before. This is always going to be increasing by 1. No matter what the transformation is, these values will always go up by 1. It's just they start at a different place. Okay. Now, so this next column, we're going to take the y value from over here. Don't be thinking you're going to be working with this. We're modifying the y value, which is over here. So that's 4 times 4, which is 16. 16 minus 5 is 11. Okay, then we got 1. So 4 times 1 is 4. 4 minus 5 is -1. 0, so 4 times 0 is 0. Minus 5 is -5. Now here's where you can use symmetry to help you out. So if you notice, the next value of y is 1, but we already saw a value of 1 over here. So this transformation process is exactly the same for both of these. So that point, and you might want to just plug it in, make sure you get the same number, but it should be, these two should be exactly the same. And similarly, we've got a 4 here, and we've also got a 4 here. So when I'm transforming this coordinate, it's going to be the same result as this. So that should be 11. Okay, and remember this point here, the one in the middle of the symmetry, that's our vertex. It's always the third of the 5 points. Okay, and that makes sense because you can see HK is supposed to be the vertex, so -1, -5, and it's confirmed here. So now we just plot these points on our graph. So I always start with the vertex, work my way out from there. So -1, -5 is right here. Okay, then I've got, let's do this point, 0, -1 is right here. Also got -2, -1, which is, we call this the mirror point. Oh, hold on, that was 0, -1, not 1, -1. So that's right here. And this point here, -2, -1, that's right down here. You can see how these 2 points are very related to each other. They're same y value and the same distance to each side from the vertex. Okay, and then our last 2 points, the big ones here, I've got 1, 11. So I guess I could plot it right about there, even though it's off the graph. And also -3, 11, which is over here. So there's my 5 points. These are exactly, exact values. There's no estimating or guessing. So when I sketch my parabola, I always draw like a little cup where the parabola is to make my smooth transition when I'm changing direction. Otherwise, people tend to draw it almost like a jagged edge here. It's not pointy. It's nice and smooth. So drawing that cup will then allow you to draw a nice smooth parabola. It doesn't have to be perfect. As you can see, mine isn't, but it's not too bad either. Don't forget, you can always, if you want to fix it up a little bit, just erase the part that you think looks kind of strange and just make it a little bit better. And there's your graph. So this graph is y equals 4x plus 1 squared minus 5. Okay, so hopefully that wasn't too bad. You can see how little actual calculation was involved. And like I said earlier in the lesson, it's important to do it this way because you notice that we always get the vertex as one of the 5 points, and that's always going to be your middle point. And then you've got 2 points to the left, 2 points to the right. That gives you a nice shape of the parabola that you can draw. If you just guess at some points to draw, there's a pretty good chance you're not even going to get the vertex. So this allows you a minimum number of points to get a nice shaped graph. Okay, one more example here. So this time you've got, you can see this is going to have a reflection and compression instead. So we'll see what that looks like. So write down our parameters. A equals -0.5. H equals, there's no number inside the brackets. So what does that mean? Well, if you think about it, we could write this as x minus 0 squared plus 4. That's exactly the same as x squared. So if you don't see a number in brackets with the x, the h value is 0, which means it's not shifted. And then k value is 4. Okay, so again, basically I could just take a carbon copy of this, base points over here. It's always going to be the same points, which will allow us to get a nice selection of points when we transform them. So -2 through +2 and 4, 1, 0, 1, 4. You'll get to memorize those very quickly. So again, those are the base points. I won't write it this time. And then when I do my transformation, here's my new table here of points. Okay, and again, let's put down our values here. The a value is -0.5. The k value is 4. And the h value is 0. So that's going to make our transformation for x nice and easy, because remember, it's always x plus h for the new x coordinates. X plus h is x plus 0, which is just x. So we don't have to do anything to these original, sorry, I should go over here. The original x values are unchanged. So that's not too hard. Just copy them back. And unfortunately, the y values, no such luck, they do change. So remember, it's, I'll write it over here this time, ay plus k. That's always the formula you use here. Usually put it above, but it's a little squished there. So the a value is -0.5, so -1/2 y plus k, which is 4. So -0.5 y plus 4. Hopefully you can see that there. So if you have to do this calculation in 2 steps, please do it. If you need a calculator, use a calculator, but make sure you just don't do sloppy math and come up with some incorrect values here. Especially watch the negative sign. That can really throw your graph off in a hurry. So remember, I'm starting with these y values here. So the first thing I do is multiply by -0.5. So -0.5 times 4 is -4/2, which is -2. And then I add 4, so that's -2 plus 4 is 2. Okay, if we plug in 1, so -0.5 times 1 is -0.5. -0.5 plus 4, that's the same as 4 minus 1/2, or 4 minus 0.5. That's going to be 3.5. And then plug in 0. Well, 0 you just get 4, because multiplying anything by 0 gives you 0. And then the 1 here, sorry, the fourth point, it's got the same value, should have the same value as, sorry, that should be negative, yeah, it's -1. Did I make a mistake there? I think I did. I didn't see my own negative sign. So let's go back and do this one. So that's -0.5 times -1, so that's 1/2. So 1/2 plus 4 is 4.5. Let me make sure I did this one right. That's, oh, I did that one wrong too. Look at that. Okay. See how easy it is to make mistakes when you rush. Okay, so if we do this one again, -0.5 times negative, oh, you know what? I'm doing what I said, warned you about not doing. I've been working with these values here, because we're kind of used to working with x values to get y values, and I should be working with these values. So the value I had here originally was correct. So -0.5 of 4 is a -2 plus 4, so that is a 2. And then this is This is 3.5, and this is going to be 4. And the rest of them will be exactly the same. These values are the same, so these values should be the same. So I got a 3.5, and the first and last values transform the same way. Okay, so that should be correct now. And you can see the symmetry again. We've got the two 2s, the two 3.5s, and the point in the middle, which is the vertex. And the vertex should be HK, and it is. So let's go down to our graph. Start with the 0, 4. So it's 0, we move up to 4. And then let's do the 1, 3.5. So 1, 3.5 is here. So it's pretty close. And then negative 1, 3.5 also. So these are pretty cramped points. And they tend to be, when you do compressions, that the points become very squished, because compressing means pushing together. Okay, and then the point at 2, x equals 2, y equals 2. And we have the similar one at negative 2, 2. So you can see how tight those points are. But you can definitely see a nice parabola there. We have to do a little bit of guesswork when we do compressions, because we have no points over here. So we just do our best. So after a while you get pretty good at this. And that's what the parabola looks like. It's a nice smooth curve. Looks even better than that one, I think. So this is the quadratic equation. Y equals negative 1/2 x squared plus 4. Okay, so you can see how quick it can be, but you can also, based on the second guessing I was doing over here, make sure that you're transforming these y values to these y values, not these to these. Okay, so the x goes to x, the y goes to y. It's easy to slip once in a while. Just make sure you're consistent if you can be. Okay, I've got some additional quadratic equations here for you to sketch, to graph using base point transformations. So that should give you some good practice. Remember, it's always really important, first step you do, pull out the a, h, and k values, and then you do your base point table, and then you apply the transformations. Okay, so I think once you get to your third one, you'll see how quickly it actually can go. It's actually much more efficient than the regular style of graphing, where you just pick 5 points at random and graph them. Okay, so that is it for this lesson. So make sure you practice all of these, and you'll be an expert at graphing quadratics. Okay, guys, that's it for today. Have a good day, and see you next lesson.